the numerator and the denominator by the same thing, our product is still equivalent to the original fraction. Do we all agree on that? Okay, so keep that in your head when we get to this method. So today we're going to, it's complex. Today we're going to simplify complex rational expressions, and there's going to be two methods. All right, so you should write this down. So there's going to be two methods. The first method is to simplify the numerator and denominator, then divide. And the second method is going to be to multiply by the least, or multiply every term, I should say. Multiply every term by the least common denominator. Okay, so let's see some examples. So I want us to simplify. And I'm going to have a half divided by 1/4. Okay, so method one says simplify my numerator, simplify my denominator. Can I simplify a half or 1/4 any further? No, they're already simplified. Then it says, then just divide them. What do I mean when I say divide them? We could just write it as a half divided by 1/4. We're dividing these fractions. And what is that special saying? Keep, change, flip. And now when you're multiplying fractions, what are you allowed to do? Cross simplify. 2 goes into 2 once, 2 goes into 4 twice. So now I'm left with just 2. Do we all agree? Okay. So that was method one. That's the method we're probably most comfortable with. Method two is something new. Method two is telling us, not 2. So we'll say this was A. Now let's look at the other way to do this. So if I have a half divided by 1/4. Before it got cut off. All right. So this is a fraction. This is a fraction where this is my numerator and this is my denominator, right? The division sign is the fraction bar is the division sign. So if I look at this and it is a fraction, as long as I multiply the numerator and the denominator by the same thing, aren't I not changing its value at all? So now what we're going to do is we're going to look at the two denominators and we're going to ask ourselves, okay, well, what is the common denominator for 2 and 4? 4. And we're going to multiply top and bottom by 4. What does that look like? That means I'm going to multiply this by 4 and this by 4. And when I multiply by 4, don't those 4's cancel? And then when I multiply by 4 in the numerator, 2 goes into 4 twice. So I end up with just what? 2. Same answer both ways, right? Lily? No. So let's Let's try a different one. Let's try, what do you want to do? Like 2/3 and I don't know, 1/6? Okay, let's try it. So 2/3 divided by 1/6. Do we agree this is going to be 2/3 divided by, I'm doing it both methods, 1/6. Keep, change, flip. So now 3 goes into 6 twice. What are we left with? 4. So that was method A. Now let's look at method B. So method B says I should multiply top and bottom by what number? 6. The common denominator for 3 and 6 is 6. So I'm going to multiply bottom by 6, top by 6. 6's cancel out. 3 goes into 6 twice. Again, what am I left with? 4. Let's say I have 5/6 divided by 4. Do we all agree this is my main fraction bar in like the complex? So this is saying 5/6 divided by 4, which is really 4 over what? 1. So keep, change, flip. Can I cross simplify here? No. So we just multiply across, and what do I get? 5/24. Okay, I can still use method B here. This was method A, method B. So method B says multiply top and bottom by our least common denominator. 4 is not a denominator, right? What's the only denominator here? 6. So I multiply top and bottom by 6. In the numerator, don't those 6's cancel? So I'm left with 5, and in the denominator, 6 times 4 works out the same way. All right, we ready to step this up a bit? Okay. Now, if I just had 3/4 plus a half, would I be able to multiply everything by 4 here and cancel out those denominators if I just had this, only this? Would I be able to multiply by 4 and cancel out those denominators? No. Why wouldn't I be able to? It's an expression, it's not an equation, right? I can't eliminate the denominator. What would I have to do here? I would have to make a common denominator. Yep, I would have to make a common denominator. And then would I be able to add them? Yeah. Okay. Then how does this, just the 3/4 plus a half, differ from this?
Because it's over something else.
Because it's over something else. So now essentially what I'm looking at is a fraction. And I'm looking at a fraction where this is my numerator, this is my denominator. And if I have a fraction with a numerator and the denominator, and I multiply the denominator and the numerator by the same thing, am I creating an equivalent fraction? Yes. It's okay that the numerator and the denominator have a plus sign in them. That's okay. As long as we have that long fraction bar, as long as I'm distributing in whatever I'm multiplying, it's still okay. So I'm going to do my method 2 here. I'm going to look at all of the denominators, 6, 12, 4, and 2, and I'm going to ask myself, what would be the common denominator for 6, 12, 4, and 2? 12. So what we're going to do is I'm going to multiply the numerator and the denominator by 12. And as long as I have a fraction, if I multiply the numerator and the denominator by the same thing, am I keeping it an equivalent? Am I keeping it balanced? Absolutely. So now I have to distribute in that 12. So this becomes 12 times 3 over 4 plus 12 times a half over 12 times 5 over 6 minus 12 times 7 over 12. So 4 goes into 12 3 times, 2 goes into 12 6 times, 6 goes into 12 twice, 12 goes into 12 once. So now I'm left with 9 plus 6 over 10 minus 7. Which gives me 15 over 3. And what's 15 over 3? 5. Okay, do you guys want to see this using the first method that I had showed you? All right, if we were using the first method, I'll let you finish copying this. Mm-hmm. All right, so let's go back and use the first method. So if I had 3 over 4 plus 1 over 2 all over 5 over 6 minus 7 over 12. For the first method, it says simplify the numerator. For me to simplify that numerator, don't I have to create a common denominator? So to create a common denominator, I'm going to multiply top and bottom by 2. So I'm going to have 3 over 4 plus 2 over 4. And in the denominator, my common denominator is 12. So I'm going to multiply the first fraction top and bottom by 2. So we have 10 over 12 minus 7 over 12. So we keep going. We're going to simplify the numerator up top, and that's going to be 5 over 4 divided by 3 over 12. Can I simplify 3 over 12? Yeah, what does 3 over 12 simplify down to? 1/4. So now I have 5 over 4 divided by 1 over 4. Keep, change. Oh, what happened here? Oh, that should be 4 over 1. Oh, wait, no, that's 1 over 4. I just have to do my keep, change, flip. 5 over 4, 1 over 4. So 5 over 4. Oops, I'm going too fast here. 5 over 4 times 4 over 1. I can cancel out the 4s. So what am I left with? Just 5. Same answer both ways, but isn't the top way a lot faster? Yes. Yes, I just wanted to show you the long way because most likely there's going to be variables in there where you can't just, it doesn't make sense. So this would be quicker. Okay, let's keep going. Let's step it up a little bit more. So now I'm going to focus just on method 2. So you've seen method 1. I'm going to focus now on method 2 since that's our new method. So I have 2 over x plus 3 over xy all over 3 over x squared plus 1 over 5. So I'm focusing on our second method here, which tells me because this is a fraction, right? This is my numerator, this is my denominator. I'm going to look at all of the denominators and I say, okay, what would be the common denominator for all of this? What would be the common denominator for x, xy, x squared, 5? So maybe besides Ariana. Besides Ariana. Philip? Good. 5x squared y. Excellent. So we're going to multiply everything by 5x squared y. So we're going to have 5x squared y times 2 over x plus 5x squared y times 3 over xy over 5x squared y times 3 over x squared plus 5x squared y times 1/5. So now I'm going to cross simplify. One of the x's crosses out, the y crosses out, the x squared crosses here, and the 5 crosses here. So now we are left with 10. Oh no, what happened? Okay, here we go. We are left with 10 xy plus 15x over 15y plus x squared y. Okay, now we have one single fraction. In the numerator, I can pull out a GCF of 5x. Do we agree? In the denominator, I can pull out a GCF of y. But will a 5x and a y cancel each other? No. Since I know if I pull out that GCF, nothing's going to cancel. Do I need to factor these? No. I can leave it just like this. If you're unsure, should you factor to be safe? Yes. Ready for the next one? Actually, do you want to try one by yourself? Try one by yourself before I step it up a little bit. Okay, you guys try this one. What number are we up to? 5, thanks. All right, so you're trying this on your own. Okay, so what did we multiply everything by? X squared, perfect. So I'm going to multiply numerator and denominator by x squared. And we're going to end up with x squared minus 6x plus 5. And in our denominator, we're going to end up with x squared minus 3x minus 10. Okay, we can factor. I'm not sure if I factor, if things will cancel. Maybe they will, maybe they won't. If I'm unsure, should I factor to C? Yes. So we're going to factor. So this is going to be an x minus 3, x minus, oh, sorry, nope, that's wrong. X minus 5, x minus 1. And in our denominator, we're going to have an x minus 5 and an x plus 2. So luckily for us, the x minus 5s cancel. It wasn't a waste of time. And we end up with an x minus 1 over an x plus 2. Can I cancel out these x's? Good. Why no? Good. Good, because it's a binomial. It's a plus sign. I can't do that. So we end up with that. How many people got this? Great. All right, let's step it up a little bit. So think back before, when we were finding our common denominators, what did I recommend you do if something can be factored before choosing your common denominator? Didn't I say factor, then choose your common denominator? Same idea here. We want to factor, then choose the common denominator. So I can factor that x squared minus 25. Isn't that an x plus 5, x minus 5? And same thing here, x plus 5, x minus 5. So now if we had to choose the common denominator for all four of these, what would be that common denominator? Violet? X plus 5, x minus 5. You got it. So now we're going to multiply numerator and denominator by x plus 5, x minus 5. So in our numerator, we're going to end up with a 2x plus 5 times the quantity of x plus 5. In the denominator, I'm going to end up with 4 times the quantity of x minus 5 plus 3x. Do I have to distribute and then simplify that numerator and denominator? Is that optional or is that a must? So do I have to distribute that 5 and do I have to distribute that 4 and then combine like terms? Is that optional or is it a must? It's a must. You have to do this. It is not optional. So we are going to distribute in that 5 and distribute in that 4. And so we'll get 7x plus 25 over 7x minus 20. All right, at this point, is there anything further I can do to simplify? There is nothing. I can't pull out a GCF. Nothing will cancel, so we stop here. All right. Can I tell you the biggest mistake I see here? The biggest mistake I see here is that students do this. This is so wrong. Why? Why is that so wrong? So it's not saying this whole quantity is raised to the negative third power where I can move the whole quantity to the denominator. This is saying just x, right, is raised to the negative third power and just y is raised to the negative third power. So I can't just move the x down and move the y down because of the plus sign. If it had been multiplication between them, if it had been x to the negative third, y to the negative third over x to negative 1, y to the negative 1, then could I absolutely just switch them? Absolutely, because it's multiplication between them. But because of that plus sign and the whole quantity is not raised to the negative, each individual term is raised to the negative, I can't just put it into the denominator because of that plus sign. So what does this look like? This looks like this. 1 over x to the third plus 1 over y to the third over 1 over x plus 1 over y. So now once we took care of those negatives, what do you think we should do now? We took care of the negatives. Now what do you think we should do? Violet? Good. Look at all the denominators. Choose a common denominator. What would be the common denominator for x to the third, y to the third, x, y? Do we all agree it's x to the third, y to the third? All right, so I'm going to multiply my whole numerator by that and my whole denominator by that. So I'm going to end up with y to the third plus x to the third over this x squared y to the third plus x to the third y to the second. Okay, so we got rid of the complex part, right? It's no more stacked fractions. Now we look at this. How many people think we're done? We're not done. Yeah, good. We're not done. Why? Why are we not done? Ira?
Because we can take out a y squared x.
In the denominator, we can absolutely pull out a y squared, x squared. And we're going to be left with y plus x. And what else? And good? Good. The numerator is a sum of cubes. So for the sum of cubes, I'm going to have a y plus x times a y squared plus xy plus x squared. And now can I cancel the y plus x and the y plus x? So now we are left with a y squared plus xy plus x squared all over x squared y squared. Oh, sorry, there should be a minus here, not a plus. Nobody caught that? Nobody really? Okay. Now we're done there. All right, we ready for the doozy? We ready? You ready for it? It's a very, very ugly looking problem. Prepare yourself. You'll probably need like at least 3/4 of a sheet.
Yeah, this is
I told you it's a doozy, okay? So it's ugly looking. We're going to start it together. So what we're going to do is we're going to start from the bottom and work our way up. And what I want to do is I want to look for a complex rational expression. What do I mean when I say I want to look for a complex rational expression? Basically, I want to look for like stacked fractions. So from the bottom here, I have 1 over 2 minus this whole quantity. Isn't this sort of a step where I can use that idea of multiplying the numerator and denominator by the same thing and simplifying it a bit? So that's what I want to do. So I want to choose my first from the bottom, my first stacked fraction, which is going to be, I'm not going to put this 2 in here because you see how that 2 isn't part of the stacking? Do you guys see that? How it's just, this is part of the stacking? That 2's on the outside, that line is not extending underneath that 2. So that 2's getting left out. So I'm just using this right here. And then I'm going to go over to the side of my paper and I'm going to simplify this. 1 over 2 minus 1 over 2 minus x. And following the pattern we've been using, we look at all the denominators. Well, really, how many denominators do we have here? Just 1, which is the 2 minus x. And so we're going to multiply the top and bottom by that 2 minus x. So in our numerator, we're going to get that 2 minus x. In our denominator, we're going to get 2 times the quantity of 2 minus x minus 1. Everybody okay with what I just got there, what I just wrote down, how I got that? All right, so now I'm going to simplify this. 2 minus x over 4 minus x minus 1. I can, oh, sorry, not 4 minus x, 4 minus 2x minus 1. So now I have like terms. I have the 4 and the negative 1. So this is going to give us 2 minus x over 3 minus 2x. And what I'm going to do is I'm going to take this whole expression and I'm going to substitute it into the box. And I'm going to rewrite it all over again. So now we're going to rewrite this all over again. So we're going to have 2 minus 1 over 2 minus 1 over 2 minus 2 minus x over 3 minus 2x. Can I keep going now? All right, so now we're going to choose another stacking. All right, which stacking am I choosing this time? Do you see the 1 over this whole thing? How come I'm not including that 2 on the outside? Ariana? Good, because it's not part of that fraction, that long fraction bar. It's not part of it. So now what am I going to do again? I'm going to go to the side of my paper and I'm going to try to simplify this. So I have 1 over 2 minus x over 3 minus 2x. Again, I only have one denominator, right? So I'm going to multiply everything top and bottom by 3 minus 2x. So in my numerator, I get 3 minus 2x. In my denominator, I get 2 times the quantity of 3 minus 2x minus the quantity of 2 minus x. Why is it important that I put that 2 minus x in parentheses? Why is that important? Excellent. So we distribute that negative. So now we're going to have 3 minus 2x over 6 minus 4x minus 2 plus x, which is going to give me 3 minus 2x over 4 minus 3x. And I'm going, oops, what happened? Okay. And I'm going to take this and I'm going to substitute it into the box. And I'm going to rewrite everything all over again. So we have 2 minus 1 over 2 minus 3 minus 2x over 4 minus 3x. All right, we're going to do the complex rational expression one more time. So here's my box, right? I'm going to simplify this. 1 over 2 minus 3 minus 2x over 4 minus 3x. And this time I multiply top and bottom by 4 minus 3x. And I'm going to get 4 minus 3x over 2 times 4 minus 3x minus the quantity of 3 minus 2x. So we're going to have 4 minus 3x over, I'm going to distribute in 8 minus 6x minus 3 plus 2x. So I have 4 minus 3x over 5 minus 4x. I'm going to take this and sub it into the box. So now I'm left with 2 minus 4 minus 3x over 5 minus 4x. I'll let you all catch up to this point. Okay. Is there any more complex rational expressions that I can simplify here? Is there anything left complex? No. Isn't this just a subtraction of fractions? Can I eliminate the denominator if I'm just subtracting, because this is 2 over 1. Can I eliminate the denominator if I'm just subtracting fractions? No. What must we create? A common denominator. Do we agree our common denominator is 5 minus 4x? All right, so I have to now create that common denominator. So I'm going to multiply 5 minus 4x top and bottom here. So I get 2 times 5 minus 4x over 5 minus 4x minus 4 minus 3x over 5 minus 4x. over here. So we're going to have 10 minus 8x over 5 minus 4x minus 4 minus 3x over 5 minus 4x. Okay, so now I'm going to have 10 minus 8x. Are you all okay if I distribute in this negative right away? Everybody good with that? Yeah? Okay. So then we're going to have a minus 4 plus 3x over 5 minus 4x. So now I can finally combine my like terms. And we're going to get a 6 minus 5x over 5 minus 4x. If I could factor, I would, but I can't, so I won't. Okay, we are done for today.